Today's light vehicles are designed to offer drivers exceptional performance, respectable fuel economy, the highest levels of passenger comfort and safety, whilst meeting stringent exhaust emission regulations. These vehicles have a vastly different and more complex exhaust emission system compared with an older diesel vehicle. A diesel particulate filter, or Dpf, is simply a device fitted to the exhaust system designed to filter and trap particulate matter from the expended gases. The Dpf has a limited capacity. As it becomes saturated with particulate matter or soot, it begins to restrict the exhaust flow. It's necessary to remove these built-up particles routinely and in a manner that complies with current emission regulations. The Engine Control Module, or ECM, does this by injecting extra fuel into the combustion chamber during or just after the compression stroke, increasing the exhaust gas temperature and burning off the trapped particulate matter within the Dpf. The Dpf assembly may be located up or downstream of a NOx catalyst. The Dpf is constructed with a porous ceramic core with alternately closed channels. The soot-enriched exhaust gas flows into the closed channel and is forced through the porous walls and out of the ceramic core. The filtered gas then flows through the rest of the exhaust system, exiting into the atmosphere. The trapped particulate matter is stored in the closed channels on the engine side of the Dpf ceramic core. The ECM burns off the stored particulate matter by raising the exhaust temperature to over 600 degrees Celsius. Remember, care must be taken when performing repairs on a common rail diesel or CRD exhaust system, as the heat generated during a service regeneration can cause serious burns and personal injury. In order to meet increasingly stringent global emission standards, exhaust gas after treatment requirements will increase significantly for CRD passenger vehicles in the future. Manufacturers are constantly improving CRD injection systems and their electronic control. The performance, fuel economy and emission levels have steadily been improved. Extremely high injection pressures convert diesel fuel via the injector nozzle to vaporised droplets. These are then optimally distributed throughout the combustion chamber. This results in greatly reduced hydrocarbon, carbon monoxide and lower diesel particulates from being produced in the combustion stage. The introduction of Euro 5 emission standards has shown that engine modifications alone are no longer sufficient to achieve any further reduction in the diesel particulate emissions. The Dpf has now become an integral component of all production CRD light passenger vehicles. The introduction of a Dpf is in response to increasingly greater environmental awareness in terms of the impact of diesel particulate matter on the health of human beings. Diesel particulates are composed as a chain of carbon particles with a very large specific surface area. The noxious effect of diesel particulate matter is a result of adsorption of unburned or partially burned hydrocarbons. The introduction of Dpf enables more than 95% of the diesel particulates to be efficiently removed from the exhaust gas. However, the complete removal of all diesel particulates using conventional methods is just not possible. The stored particulates must be regularly burnt off in order to prevent blockage of the Dpf. The saturation level of the Dpf is calculated by the ECM. If it exceeds a certain threshold, the ECM initiates a regeneration or burn-off process by means of fuel enrichment through pre- and/or post-combustion injection events. The additional injection events increase the temperature of the exhaust gases to greater than 600 degrees Celsius. In a correctly functioning system, this extreme heat energy converts the carbon deposits or particulates to carbon dioxide and trace amounts of hydrocarbons and carbon monoxide. The engine control module, injectors, exhaust gas temperature and differential pressure sensors are responsible for the control and monitoring of this regeneration process. There are 3 types of Dpf regeneration possible in a CRD passenger vehicle: passive, active, and forced regeneration. Passive, active, and forced regenerations can affect the service life of the vehicle's engine oil due to the manner in which these types of regenerations are performed. Diesel fuel quality impacts heavily on the level of particulates produced by a CRD engine due to high levels of sulfates in some diesel fuels. This results in more frequent regeneration events. Most vehicles fitted with a Dpf need a low ash engine oil to help prevent premature blockage of the Dpf. Want to know more? We'll have a detailed look at these 3 regeneration processes in the following series of Dpf videos. Dpfs must be designed to comply with the vehicle manufacturer's specifications. This will determine the quality of cheaper aftermarket Dpfs compared to the original equipment manufacturer, OEM, that are generally more expensive. Our Ryco range of Dpfs are built to exacting standards to meet or exceed genuine alternative Dpfs. When a workshop makes the decision to purchase an aftermarket Dpf, they must ensure it meets the vehicle manufacturer requirements and not risk voiding the vehicle warranty. When purchasing a replacement Dpf, several factors must be considered. The substrate size must be compatible to the engine capacity without causing a reduction in engine performance. We match the exhaust pipe diameter with the original equipment manufacturer. A smaller diameter pipe to OEM results in a back pressure increase, which may affect engine performance and illuminate the Dpf warning light, or even enter a reduced power mode. Failure to use an approved Dpf will often result in exhaust tailpipe emissions not meeting vehicle manufacturer compliance, which may result in environmental penalties. So now, we have a reasonable understanding of a diesel particulate filter's purpose, construction, location on a vehicle, and its functionality in reducing tailpipe emissions. If there is any part of this video you are unsure of, please review it again. It's important that you have an understanding of a diesel vehicle's engine management system's control of exhaust tailpipe emissions.